Hey, we're going to look at solving radical equations. So when we solve radical equations, we kind of start off the same way we solve any equations. Any equation that we ever solve, we want to get x by itself equaling something. So usually we try to say, well, what's happening with my x? In this case, my x is underneath the square root. Since my x is underneath the square root, I know that I'm going to have to get rid of the square root. Opposite operation of a square root is going to be a square. So if I square a square root, that's going to cancel out. Of course, if I do something to one side, I got to do it to the other. So I'll square the 4 and I'll get x equals 16. I always want to check. So I want to go back and say square root of 16. Yeah, that does equal 4. And done. So look at the next one. Say I have square root of x minus 2 equals 3. Again, I have a radical. So I know that I'm going to have to square. So if I do square, then I'm going to get x minus 2 on the left side, because squaring a square root will cancel it out. On the right side, I'll get 9. Continue solving. I'll add my 2 over. Get x equals 11. Always want to check. So if I sub in 11, I'll get 11 minus 2 is 9. Square root of 9 is 3. So 11 checks out. Okay, so I'll try another one. So square root of x plus 7 equals 1. Again, I have a square root. Since I have a square root, I'm going to have to square so I can cancel it out. So I'll square and I'll get x plus 7 equals 1 squared is 1. So x equals negative 6. Again, I want to check. Negative 6 plus 7 is 1. Square root of 1 is 1. So it works out. So that's a basic idea. Whenever I'm working with equations with radicals, if I see a square root, I know I'm going to have to square it. Everything else is just trying to make it easier for us. So if I have something like, say, square root of x plus 5 minus 1 equals 3, I don't actually want to start off by squaring. If I start off by squaring, that means I'm squaring both sides. If I square my left side, this is 2 terms. So it's a binomial. I know that when I square a binomial, I have to FOIL it. I don't want to FOIL this. So instead, I'm going to rewrite this real quick. Square root of x plus 5 minus 1 equals 3. So instead, I'm going to add my 1 to both sides. I'm going to get square root of x plus 5 equals 4. And I'm going to square from there. If I square from there, then I'm again squaring a square root is going to cancel out. I'm going to get x plus 5 equals 16 and x equals 11. I can check. If I sub in 11, I will get 11 plus 5 is 16. Square root of 16 is 4. 4 minus 1 is 3. So it does work out. So here I got square root of 2x plus 3 equals 4. This is fine for me to square right away. I got square root by itself. If I square it, I don't have to FOIL. I don't have to do anything strange. So I can just square it immediately. I'll get 2x plus 3 equals 16. And I can solve from there. 2x equals 13. X equals 13 over 2. This seems like it'd be harder to check. But since I'm subbing it into x, that 2 is going to cancel out almost immediately. So I would get 2 times 13 over 2 is just 13. Plus 3 is 16. Square root of 16 is 4. Okay. Let's try another one. Say we have 5 times the square root of x plus 4 equals 10. Okay, I could square it immediately, I guess. But it'd be easier again for me to just get this square root by itself on one side. So I'm going to go ahead and divide both sides by 5. So I'm going to get square root of x plus 4 equals 2. Now I'll square both sides. Get x plus 4 equals 4. And x equals 0. Again, I can check. If I sub in 0, I'll get 0 plus 4 is 4. Square root of 4 is 2. 2 times 5 is 10. So it is going to work. Okay, so let's try a few more. So say I have square root of x plus 2 equals x. Got my square root by itself. It's not going to be weird. I'm not going to have to FOIL anything. So I can go ahead and just square right now. I'll get x plus 2 equals x squared. If I squared x, I just get x squared. So I have a quadratic. I know I have a quadratic because I have an x squared. I know whenever I have a quadratic, I get everything over to one side equal to 0. So I'm going to subtract my x and subtract my 2. So I get 0 equals x minus 2, x plus 1, and x equals 2 and negative 1. Again, I want to check, so if I put in a 2, I'll go ahead and get square root of 2 plus 2 equals 2, and that would be square root of 4 equals 2. So yes, 2 works. If I put in a negative 1, I'll get square root of negative 1 plus 2 equals negative 1. So square root of 1, does that equal negative 1? And no. Square root of 1, by definition of a square root, is just a positive root. So negative 1 does not work. Even though I did the math correctly, by definition of the radical, it's not going to work. Okay, so let's try another one. Say I have square root of x plus 2 equals x minus 4. So again, I can square immediately because my square root is by itself. I am going to have to FOIL, but I'm going to be foiling this x minus 4. I'm comfortable with foiling x minus 4. I've done that a ton by now. So I'll go ahead, FOIL it out, x squared minus 8x plus 16. And on the other side, squaring a square root, I'm just going to get x plus 2. Again, it's a quadratic, so I'm going to get everything over on one side equal to 0. So I'll get x squared minus 9x plus 14 equals 0. So x minus 7, x minus 2 equals 0. So x equals 7 and 2. I want to check. If I try 7, I'll get square root of 7 plus 2 is 9. Square root of 9 is 3, so I'll get 3 on one side. On the other side, I'll get 7 minus 4, so 3. That works. You can check with 2. If I do 2, I'm going to get square root of 2 plus 2 would be 4, so square root of 4 is 2. On the other side, I'm going to get 2 minus 4 is negative 2. So again, not going to work. My only answer is 7. Okay, let's try the next one. So say I have the square root of x minus 1 plus 7 equals x. If I square immediately this time, again, I'm going to have a binomial with a radical, and I'm going to have to FOIL. I don't want to FOIL if I don't have to with a radical, so I'm going to subtract a 7. I'm going to get square root of x minus 1 equals x minus 7. Now I'm going to square, and I'm still going to have to FOIL, but I'm foiling an x minus 7. I'm much more comfortable and used to doing that. So on the left side, I'll get x minus 1. On the other side, the x minus 7 whole thing squared. Y'all should be good at doing this by now, so I'm just going to go ahead and write it out. Should be x squared minus 14x plus 49. So if I go ahead and get everything equals 0, x squared minus 15x plus 50. So I need to factor this. Things that multiply to positive 50 add to negative 15. So x minus 10, x minus 5. So x equals 10 and 5. I want to check them. If I do 10, I will get 10 minus 1 is 3. Sorry, 10 minus 1 is 9. Square root of 9 is 3. 3 plus 7 is 10. So I get 10 equals 10. If I try positive 5, I'll get 5 minus 1 is 4. Square root of 4 is 2. 2 plus 7 is 9. If I put it on the right side for my x, I get 5. 9 does not equal 5. So 5 is not a solution. My only solution is x equals 10. So you always need to check for these. Okay, let's try the last two. Say I have square root of x plus 4 minus 1 equals the square root of x minus 1. I'm going to start off by squaring both sides. The reason I'm going to start this off by squaring both sides when I haven't the others, or not all the others, is I have two radicals. So no matter what I do, I am going to have to FOIL something with two terms with the radical. Before I could avoid that. I could get my radical by itself so I didn't have to FOIL something with the radical. I can't avoid that anymore. So I am going to have to go ahead and write it out twice. So let's see, square root of x plus 4 minus 1 times square root of x plus 4 minus 1, and FOIL it. If I multiply first, that's the square root of x plus 4 squared. Square root of x plus 4 minus 1 will be minus 1 square root of x plus 4. Minus 1 times square root of x plus 4 is minus 1 square root of x plus 4. And minus 1 times minus 1 is plus 1. So let's see, square root of x plus 4, that squared is just x plus 4 minus, these are like terms, the 2 square roots of x plus 4, so minus 2 square roots of x plus 4 plus 1. On the other side, square root of x minus 1 squared is just x minus 1. Okay, so I still have a radical. Since I still have a radical, I know I'm still going to have to square both sides. I don't want to square both sides right now. I want to go ahead and try to get my radical by itself. So to combine some like terms and move stuff over. So I'll minus an x, minus a 4, minus a 1. So I'm going to go ahead and get, let's see, minus 2 square roots of x plus 4 equals, x's will cancel, minus 1 minus 4 is minus 5, minus 1 is minus 6. I'll divide by my negative 2, so square root of x plus 4 equals 3. Now it's pretty easy. Now I can square both sides and it should work out nicely. X plus 4 equals 9, so x equals 5. I do want to check if I sub in 5, 5 plus 4 is 9, square root of 9 is 3, 3 minus 1 is 2. So I got 2 on the one side. On the other side, I have 5 minus 1 is 4, square root of 4 is 2. So it checks. So that should be my answer. Let's try it with the next one. So the next one I have square root of 2x plus 1 minus 1 equals square root of x plus 4. So again, no matter what, I am going to end up squaring stuff with the square root. So I might as well go ahead and just do it now. I'm going to write it out twice so I can FOIL it. So let's see, square root of 2x plus 1 minus 1, square root of 2x plus 1 minus 1. If I multiply this out, I'm going to get square root of 2x plus 1 times itself, so squared. Square root of 2x plus 1 minus 1, times minus 1, so minus 1, square root of 2x plus 1, minus 1 times the square root of 2x plus 1, and minus 1 times minus 1, so plus 1. On the other side, I'm just squaring the square root, so it's going to cancel. I'll get x plus 4. Okay, so let's see. My squaring of that square root, just make it 2x plus 1. Square root of 2x plus 1s are like terms, so I have minus 2 of them. My plus 1 is still there, and then equals x plus 4. Still have a radical, so I'm still going to have to square again. So I might as well try to get that square root by itself on one side. So I'm going to subtract my 2x and subtract my 1's. So I'll be left with minus 2 square root of 2x plus 1 on the left side. On the right side, if I subtract the 2x, I'll have minus x. If I subtract the 2 1's, I'll have plus 2. Okay. Hey, so from here I have a few options. I could divide by negative 2, but then I'd be creating a fraction where I already have a radical. So instead, what I'm going to do is from this point, I'm going to go ahead and square. So if I square from this point, on my right side I still have two terms. I have a negative x and a plus 2. So I'm still going to have to write it out twice and FOIL it. So if I do that, negative x plus 2 times negative x plus 2, I'll get x squared minus 2x plus 4. So x squared minus 4x plus 4. On the other side, I only have one term. It's a minus 2 times the radical, so there's no plus or minus in between, which means I can distribute that too. When I have a monomial, something like, say, 3x to 6, whole thing to the 7th power, it's a monomial, that's when you can just distribute the radical. Okay, so I'm just going to get 4, because negative 2 squared would be 4, and then 2x plus 1. Square root of 2x plus 1 squared. They were being multiplied because there's no plus or minus between them. So I'm going to keep them being multiplied. So 8x plus 4. Okay, quadratic, I'll get everything over to one side. So I'll get 0 equals x squared minus 12x, factor, pull out an x, and I'm going to get x to equal 0 and 12. I'm going to check both. If I put in 0, I'm going to get 2 times 0 is 0, plus 1 is 1, square root of 1 is 1, minus 1 is 0. If I put it into the other side, I'm going to get 0 plus 4 is 4, square root of 4 is 2. 0 does not equal 2, so 0 is not an answer. I'm going to try it again with 12. If I do 12, I'll get 2 times 12 is 24, plus 1 is 25, so square root of 25 is 5, minus 1 is 4. If I put it on the other side, 12 plus 4 is 16, square root of 16 is 4. So 12 does work. 12 is my only answer.